Hey guys, how's it going? All right, there was a little mix up in the schedule, but I'm speaking now, so let's get started. All right, real-time rollups and Bitcoin security. Can we have both? All right, I think I'm gonna have to do it this way. All right, I'm Shane, founder of Stargaze. Stargaze is an app chain for NFTs and more. You may have heard of Barricade or Celestine slots. Anyone have a Barricade or a slot? All right, now lick your elbow. No one's going to do that? All right, fine. Let me see. In a previous life, I built low latency audio engines for iOS music apps. And then before that, worked on scaling Web2 apps at Groupon. There's a bit more, but I'll save you guys that background. So I'm going to talk about real-time rollups without sacrificing the values of crypto that we all know and love. And I'm going to define real-time here as a Web3 query or Web3 or write that's as fast as the Web2 API call. So the thesis for Stargaze has always been that NFTs are kind of like a stepping stone to bringing more users into crypto, and we want to build the best possible crypto UX. The approach that we've always kind of taken is more bottom up than top down. There are a lot of projects in the infra space, especially, that are kind of starting with the end game first. But this is kind of a little precarious because sometimes you may end up building stuff that people actually don't want. So when you build with a bottom-up approach, when you build the app first, then it's easier to have product market fit. You can get user feedback, you can iterate quickly, and this is how things traditionally kind of work in kind of the rest of the non-crypto space. So lately, you guys probably heard about the modular thesis. It's kind of an interesting way to scale. The kind of philosophy is that you break things into components and you scale each component instead of scaling like a monolithic chain. So one way to think about that is you have a computer, you have separation of concerns, you have CPU, GPU, and RAM. You can like loosely map that. Maybe GPU is like execution, CPU is like consensus, RAM is like data availability, and then you optimize each one. And why do you want to focus on performance and UX? Speed is essential for any kind of consumer or like user-facing product. Google kind of, I mean, there's examples in history that kind of proves this out, right? Google partly won the search engine wars because it was much faster than like AltaVista and Yahoo and the other solutions that were out around that time. You can get a result in half a second instead of waiting 2 to 10 seconds. Another example is Uber internally really focused on the time to find a car. And they trained this like transformer model with like graph theory to be able to find like the shortest time to find a car. Amazon has like the 1 day shipping, right? In the context of crypto, if you make a blockchain super fast, it attracts more users, and then they'll add more TVL. You'll have more volume, and then in turn, you can learn from them, improve the UX. And then you have more users, they'll come do more transactions, you'll have more TVL, and you kind of create this like positive feedback loop. So we kind of look at where users spend a lot of their time. And a lot of people are focused on like optimizing the transaction part, but users actually spend most of their time querying the chain. They spend their time like looking for yield opportunities or like finding the perfect NFT or whatever, right? There's not enough focus on optimizing like the lead side of things. So we kind of initially focused on optimizing reads, and we have this real-time index service built in Rust. It's async and multi-threaded, super fast. you can like throw a bunch of CPUs at it, and it kind of scales, and you can like index big chains like osmosis in under 5 hours. And then the other part of it is optimizing like the RPCs for reads. So we have like read optimized RPCs where most of like the Merkle trees like cache and RAM, so you have fewer disk reads. And we're working towards like a newer version of it where we store an entire Merkle tree in RAM. And then the other side of it is optimizing writes. So there's two ways to do this. You can scale the L1, or you can build rollups and L2s and separate consensus and execution, right? So scaling in L1s, like the Solana approach. There's also, if you guys go check out Debs from Osmosis, he did a really great talk on optimizing tenement or common BFT, and looks like you can bring that down to like a second or so for block times, right? And if you combine these two, you're gonna have like incredibly fast block speeds. All right, so why scale with rollups and L2s? You just have better separation of concerns. You do one thing, you do that one thing really well, and if you could reduce the speed, the latency to the speed of execution. And then the other thing is you get fractal scaling, right? So if you need to scale the L2, you can launch an L3 and so forth. Another interesting thing about this is that as an app developer, if MEV is like the largest source of revenue, like that's yours. You kind of want to own that, right? You don't necessarily want to leak all the MEV to the base layer. So Celestion Rollkit is one way to do this. In Rollkit, you can have Cosmos SDK as the execution environment. So you can have like Cosmos WASM or like EVM or whatever on it. There's no tenement, so there's no rounds of BFT. And it also uses libp2p, which is a kind of more modern networking stack that is apparently less buggy than the tenement one. All right, so you can get really fast pre-confirmations with Rollkit, right? So the speed of execution is super fast. So that's like, maybe like 1 to 5 milliseconds or so. But you can get really fast pre-comps. You can get like 100 to 150 millisecond pre-comps. So, now we're getting into the territory of like a Web 2 like click for a transaction. All right, so sequencers are like, at least in the Ethereum world, known to be really centralized. How can we give it some guarantees so it's more secure? And one approach I like for that is Bitcoin staking. So the way Bitcoin staking works is that the sequencer will lock up some Bitcoin on the Bitcoin side, and then it signs this extra transaction when it's doing the sequencing with the same key. And if it double signs, then it exposes that key. And then when that key is exposed, someone can go in and slash their stake on the Bitcoin side. And so this can like prevent the sequencer from cheating. And the reason I kind of like this is there's no additional level of hypothecation, right? It's just staking, it's not restaking. And of course, all the other nice things about Bitcoin is credibly neutral, is the most dominant currency, and there's a lot of capital out there, and a lot of people looking to earn yield on their Bitcoin. All right, so now I'm going to go into show mode a little bit and talk about Astro. So, so everything I just talked about is so we're building this rollup, and the goal for it is to be super fast. It's going to have Cosmos WASM written in Rust, so contracts run at near native speeds, and it's also going to have native yield. So we're working with like Stride and Noble and some others. And the way this works is that as a user, you just you can transfer Atom to the L2, and then it automatically starts earning yield. And it's like just you're earning yield in your wallet, right? So like the UX is going to be like awesome for that. It's also going to run the skip block SDK, so you can collect MEV and you can like share it with the base layer if you want. So a lot of people ask me, oh, why Stargaze doing this, right? Stargaze has to kind of evolve beyond NFTs. Right now, the way I think about it is kind of like when Amazon was just like selling books, right? You have to grow, you have to expand. We have a lot of users. Those users want to do other things. And you know, the only way to do it is to kind of launch more products and kind of service their needs. And it's going to be permissionless, so anyone can deploy contracts on it. But Stargaze L1 is still going to be permissioned, so it has this base layer that is safe, safe and secure. So this is going to open like a whole new class of apps, right? So like if you think of like a social media like or whatever, right? Like making stuff like that is going to be possible on Astra. It's going to have native yield in some of the Cosmos tokens, also stables, and it's probably going to be the first rollup that also has Bitcoin native yield. So after Babylon launches, there's going to be like restaking providers for Bitcoin, and those can be like we can like wrap around that and have native yield in Bitcoin also on Astra. So I'm just going to kind of dive in a little bit and show and talk about how it's going to work. So this is an example with a Cosmos asset. Let's say stars in this case. So let's say you want to transfer stars to Astra. The way it works behind the scenes is that it'll get liquid staked on Stride, and then it uses this thing called a hyperlane yield route. And it gets locked in a vault, so the staked version gets locked in a vault, and then there's this contract that calls like a rebasing function every like 6 hours or so, and then that it mints like new versions of stars that flows into your account, and it can also flow into contracts, right? So if you're an app dev, now you have this like yield flowing into your contract. So this like opens the door for new kinds of things that you could build, right? So some of that yield could like be revenue. Some of that could like flow to the users as like a reward, right? So kind of really looking forward to what people build with this. The other thing is it's now going to have a dispute period. So if you use L2s on Ethereum, like Base and Blast, you have to wait like 2 weeks if you want to go from the L2 to the L1. There are other ways around this. You can use other bridges, but then you got to pay like an extra fee for that, right? So just real quickly, the way this works, and by the way, Yermo did a whole talk about this, so go find his talk at Modular Summit. But the way this works is that the validators in Stargaze L1 will run full nodes of Astra, and then they're able to get the latest state and verify the rollup. And it can update the light client on the Stargaze L1 side. So now you have this like validating bridge between the rollup and between the L1. So you can just do like IBC transactions. And this also kind of opens the door to like, let's say there's another L2 on Stargaze. So you can now do like IBC routing between the L1 and the L2s. So you could possibly have like atomic execution where like rollups could talk to another rollup to like route it through the L1. So show mode off. I think I went a little fast, but in summary, with real-time rollups, you can have awesome UX. You can have like whole new classes of apps. You can have this like really fast like user adoption loop. You can have users come in and add more TVL and bring in more users. You have this like native yield that flows into your apps, and you can have scalable security with Bitcoin staking. And yeah, that's it, folks. If you want to learn more, you can follow me. Shane3V on Twitter, or Astra, or Stargaze. Thank you all. Well, actually, anyone have any questions?
So are all assets on Astra like liquid staked assets? Like you effectively turn them into liquid staked assets?
No, all assets don't have to be liquid staked assets.
Got it. So not all assets are inherently yield bearing on Astra.
I mean, but if they are yield bearing assets, then we do want to go do Stride or go to another provider or something like that.
Got it. Very cool. Thanks.
Do you plan to replace the layer one with this Astra layer, or why are you building Astra?
Because we want to build something that's really fast, right? And right now, we want there are other teams that are working on scaling the layer one, right? And we want to separate execution and consensus to build the fastest possible experience, right? So right now you can't build that on the layer one, right?
So how much TPS do you need?
Haven't really kind of looked at those numbers yet. We still have to figure out the metrics. But I mean, in theory, it's going to be much faster than the layer one, because you have this another level of abstraction on top of it.
I wonder how many transactions per second Amazon is doing.
I'm sorry?
I wonder how many transactions per second is Amazon doing on the e-commerce, no? Because you said Stargaze can become like Amazon selling any product as an NFT, no? So I wonder how much scalability do we need?
I mean, yeah, I mean, we can talk offline and kind of figure out the math there, but yeah.